Hello ladies and gentlemen, this is going to be the video that I have for the Hawaiian Islands Impactor. So in theory, what I had always thought of back when I was still going along with the plate tectonic stuff, and I was expecting that Hawaii originated from, say for instance, the west coast of the United States, and these scores weren't Jupiterian stripes, but basically scores dug into the surface of the earth from extrusion out from underneath the North American continent. Totally away from that now. Totally. Okay, so what does that mean? Well, it means that we have something out in the middle of the ocean, islands, and we call it the hot spot. Well, yeah, it's a hot spot, all right. It's kind of like having a balloon with a hole in it, but the balloon never deflates. So under closer evaluation of the Hawaiian Islands, I kind of decided that the radial subterranean lines coming out away from the islands was not like stretch marks. Say for instance the earth for some reason kind of like in between my fingers is Hawaii and it just goes beep. Well, apparently that didn't happen. All right, so it wasn't a planetary fart beep, or it wasn't anything like that at all. It was actually an impactor in and of itself. And so the Hawaiian Islands were created by, at least in a much greater part than not, by a space rock. Yep, that's right. And so when we start to look at all of the evidence that the Earth is showing us, eventually we're going to realize that impactors from space have a much greater outcome and result on our planet than we've ever given them credit for before. So when you look at this kind of thing up here, you kind of have to figure out, well, what could have caused what to happen, who occurred first. And I've got blast rings out here that I can barely see, but I can still mark them. And Hawaiian Island Impactor, at its least, had the greatest ring at this range right here, which we can look at later. But you can see as the planet is in its current galactic flight posture, this puts a poo on our Hawaiian Island Impactor that takes us back behind the planet. So another impactor strikes us from behind. What is the likelihood of the planet's elevation within the galaxy? Well, the planet probably was down closer to the galactic equator or the galactic plane, where matter within the plane is moving much more quickly than, say, for instance, our solar system. And then when those objects stray from, they're basically slung out, they end up clobbering us as we come in close to their trajectories. And that happens, or that's most likely going to be a higher risk for our planet and our solar system when we are at the TRO, the lowest point in the waves of our galaxy's supermassive electromagnetic gravity waves. The SMEGAs is what I like to call them, right? And it also tells us that we're most likely at our solar minimum. So when the sun is at its solar minimum, it's least agitated by the waves, and it's down, and so we're down here. So when the sun is nice and happy, we're getting clobbered, and we get clobbered from behind more likely than from the front. As we go in between the TROs, as we're rising and falling, descending, ascending along the SMEGAs from the TRO to the crest, we're at a higher risk of being clobbered from the front. And then when we are at the highest elevation of the wave at the crest, that's where the wave is doing all that foamy weird stuff, right, and agitating the sun's surface, and that gives us solar maximum. And so it's during solar maximum that we're actually probably safest from projectiles flying through the galaxy, just not safest from the sun. So it's a crazy world out there. Crazy galaxy, right? Anyway, this was a low angle trajectory on this one, and that's why your B2W is pointing away from it. So as I've said so many times before, low angle, here's my left hand is the Earth, and low angle is my right hand, and it comes in, it goes bam, and it kind of bounces off, right? Well, it's sort of the way it hits here, and it sprays all that stuff out this way. The radial lines we see coming away from our impact site going toward the west coast of America are really radial whip shock veins. So the energy, first of all, the rock is hot. It strikes the ocean. The ocean is cold. And when you have hot things strike cold things, the cold things tend to fracture, okay, like glass. So the ocean floor, that's why it's in the ocean floor that you only ever find radial or any kind of whip shock vein. And when I say whip shock vein, a vein is basically sometimes when you have two large forces of stone and they're coming together and they compress against each other, we end up with veins of different types of rock and sometimes gems and things of that nature, right? In the surface of the earth. Well, that's why these are veins, because they're not just, stripes going down the planet. They're actually severed sections of crust. And that section of crust is going who knows how deep, right? Deep enough that it was freed to separate and slide. So the energy travels through these veins, it whips them like if I was to take a bath towel and go, that's what's happening with these whip shock veins. That's why I gave them that name. I couldn't think of a better way to describe what it is that's going on. And how do I know that it's actually whipping them? Well, there is one certain point in the southeast Indian Ocean where the whip shock vein severed a mountain range under the ocean that was about 16 kilometers long and pushed that entire severance north by northwest 8 kilometers. That's how you know it moved it. It was like, bam! That's the kind of energy, and when you could just imagine that kind of energy. So let's say, for instance, the day that we were all on the KD range, that's called the known distance range. That means when you're in the military and you're shooting at targets, the targets just pop up, boop, 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 boop. But they're at known distances from your firing point. Well, we were on this range and we're all out there shooting, doing our thing, And at this point, it was my turn to go out to the end of the range with a bunch of guys, and we're sitting there taking little black sheets of paper to put them on this black silhouette to cover up the holes so that we could continue using the same silhouettes, right? And then suddenly everybody just stops. We're like, what is going on? We're looking around at each other, and this is relatively recent, right? And then we were like, there aren't any trains right here. What in the heck? Where the heck is this train? Next thing you know, we're like, now you see him? Now you don't. Now you see him? Now you don't. The waves of the ground beneath us were so intense that we were actually rising to where we could see down like we were in a theater at the other end of the range, and then falling to where we couldn't see the guys anymore. It was like, whoa, that is creepy. And that was just an earthquake. And the sound of that was so immense that it stopped everybody. We're all like stunned. We're like, what is going on? WTF, that kind of thing, right? So that's just a small thing of what happens when these whip shock veins actually go through the surface of the planet. You could only begin to maybe imagine the type of noise that would make for us in our atmosphere. Well, anyhow, those all go out this way, and they're going out this way because the rock struck us from behind, and so they ended up spraying out in the same direction that the rock was flying in, toward the earth. Okay? And now I'm going to go to my PowerPoint, Death by PowerPoint. These are the Hawaiian Islands, and then down here you have that one. Yeah, it's like, is that one called Hawaii? Well, anyway, you notice that my impact site here isn't really an island at all. It didn't make that, it's still a hole. And the funny thing is, nobody's ever noticed this before. So if you look down here, and you've got my little pocket hole right here where that round impacted, it has the spray trail right behind it, nice pretty tail. And then you have your bat wings going out like that. Yep, that's the footprint you get with a low angle impactor. And when you go and you compare that to Little Tully Woolly in Australia, you're like, whoa, right? Little Tully Woolly had a vertical angle above the surface of the earth at approximately 2.5 degrees. That's why Little Tully Woolly may have broken up into two parts, one dug in. So basically it was flying, if I can do this right, it was flying like this, and so you had the one underneath, when they broke apart, the one underneath was slammed into the ground while the other one was pushed out, I don't know if you can see me, pushed out like this. So the top one ended up going over here and burrowing and then creating a ricochet furrow and going out that way toward the great reef of somebody or other. So that's kind of what you get there, is a double whammy, so to speak, right? Well, you might have had more than just a double whammy here in Hawaii, and basically what I'm suggesting here is each and every one of these lumps that makes up the islands in Hawaii are actually probably impact sites of subsequent impactors in sequence from right to left on a particular attitude from the impactors, the primary impactors, direction of flight. Okay, it's heading. So you end up with a linear sheaf in this instance rather than a converged sheaf. And then we come down here, we get our poo. Our poo here is like 200.35 degrees. Look right here, see that little bump right there in the middle? That's a hole, ladies and gentlemen. All you scientists that are watching, if you ever watch my videos, I might teach you something, right? Unless you already know it and you're just not telling everybody because there's some great big government conspiracy going on, who knows? But the point thing is here, that's a freaking hole. So it goes right here and it gets buried in there, and it kind of like raises all the clump garbage back over here. And then boop, 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 boop. All this is created by spray. All that B2W backed up gobbledygook goes and builds up, and then suddenly next thing you know, people are living on it. Imagine that. That's why it's a hot spot, folks. It's because it, you wouldn't say that it punched a hole in the earth, because I mean you've got Kilauea and Mauna Loa over here on Hawaii, and you're like, that's not even where the impactor struck, so why is the hole over there? I don't know. Well, that's for scientists to figure it out. I'm just the artillerist. I can tell you where the impactor struck. Can't tell you why the hole's on the other side. But you see, in reality, the hole isn't on the other side. The hole is right here, and the hole is way, way bigger than that. It's almost as large as the island itself, the actual hole. So these are my coordinates if you ever want to check that out. And the scientists, you guys get the funding from the government. Take your boat out there to that pop. That's the point of penetration. And get a core sample. Oops. It's time for me to go to work. Okay, I'm going to speed this up, ladies and gentlemen. I know you're happy about that. So here it is. This is I'm measuring this to make that determination to find out what the size of that impactor was. I also had to go back to my illustrations for the Little Tully Woolly impactor, because to determine the size of the impactor and determine that impactor's trajectory, you have to actually do things differently than you would with high angle impactors. It's a little more complicated. So I'm not going to go into, excuse me for scratching my nose, go into a lot of detail. This is the blast ring for Tahiti. All right. And those are my blast rings over there for the Yabo. And of course this is my B2W for the NPOI. And go back down here and look at all this stuff. Okay, we're getting the radii for all of this hoodly-gaggett stuff. And then we come down here. Okay, this is where I'm going to go back and look at Little Tully Woolly. And then I figure out what it is, how I figured out Little Tully Woolly. And then I'm like, oh, okay, I'm good. Then I come down here and, you know, my back azimuth is 20.35 degrees. So from the poo, right? So up in this direction is, I had to do that to figure out in order to be able to come up with the something or other. So there you go. That's where it is. All right, there's me rotation right there. So basically this arrow is at 18 degrees and north is oriented where it should be. Okay. That's where I'm checking stuff out, right? And that's how I was able to situate my oval footprint for my low angle impactor. Your low angle impactors almost always have this oval. I say almost always because right now it's always. Every time I see a every time. There's only two that I can speak of: Hawaii now and Little Tully Woolly. All right, here's Little Tully Woolly again. You know, the center of the pop to the edge of blah blah blah. Okay, so here we are down here. And this was my first one. I kind of didn't quite get it right. And I'm going to zip all the way forward down to here. Sorry to be cutting everybody short and all that good stuff. But, so this impactor was 3.2 kilometers smaller than a flying mountain Rainier. All right, see? So, you know, flying mountain Rainiers can actually create places for people to live. Okay, so here it is at 22.4 kilometers in diameter is my estimation for that guy. In case nobody knows what I determined for its vertical angle, you can see it right here. The Hawaiian Impactor had a vertical angle of 15 degrees. So when you're standing on the ground like this, okay, well, watch my fingers. I can't, it's really hard to do that. So 15 degrees, so my palm is where I'm standing, and I'm going to raise my sights 15 degrees at a vertical angle. This is the vertical angle. 15 degrees, and I'm going to look into the stars that way, and then I'm going to try to determine where was the planet when this impactor struck in relation to its coordinates, its galactic coordinates, and its solar system coordinate, and its axial tilt, its axial cant. All these things come together to tell you where it had to be, and you have to know where it was and how everything was functioning to be able to actually truly say that's the poo. The poo, point of origin, poo. All right, okay, I gotta go. I gotta go to work before I get late, and it's bad enough. Yeah. So there it is, folks. I'm gonna go ahead and kill this now, and I take that back. Stop my video. All right, don't forget to like and do some other thing like subscribe. All right, bye.